it is indeed a great honor and pleasure to be a part of a discussion, which I think is the most important aspect of any educator who is looking into the future of engineering education, typically in the backdrop of what we say as the transforming world and the AI era. This topic is more of a deliberation, but I nevertheless tried to consolidate all these in the form of some slides. And the whole idea is to uh, sort of have a brainstorming on what we should perceive as ideal engineering education for a transforming world. The picture that you see is the new gateway of entry of IIT Kharagpur, which has been built a couple of years back, and it is resonating the whole idea of refreshing the entire perspective of technical education and see how it evolves. And how, when you say how it evolves, as people in higher education, we are often insensitive to the nature of evolution of education, not just in the higher education sector, but also how education transits from its school level foundation to something which gets into more and more quote unquote advanced. If you look into bookish education, so there is a cartoon here which symbolizes physics, chemistry and maths education starting from the school era to the era of college and university. So on one side you see simple cartoons and pictures and maybe small number based calculations to reflect the foundations of certain things which are much deeper, maybe much more involved, but having the same root on which the foundation education was established. A major challenge in developing the education in any era, be it the modern era or even in the past, or perhaps what would be done for the future, is to remain sensitive to this connect. I know it's not that easy to do. And I think that one aspect of the answer to the question of what should we all do as educators to build up the engineering education for the future lies in connecting some of the school level simplifications to advanced level abstractions. At the same time, even at each level, so one is a change of level, which is more what you say as change of position, but at a given position, you have the nature of teaching learning has evolved over the years. So this is a simple cartoon which a part I gathered from the internet and then I constructed some questions. So the topmost thing, so things have got simplified and sometimes simplification is desirable, but what you all see is something which is leading us to an era where education is more teaching us of simplified things with an effort of eliminating the answers which are obviously incorrect. Look at the diagram. So there is a green piece of land and a good old school level mensuration question paper would be to find out the surface area of this. So you have a full rectangle and minus some parts of the circle, and it will give this entire area. Not a difficult question, but a standard question. Now came the era of those educators who found that we should simplify. So the first act of simplification is simplifying the geometry. So you make it a rectangle as simple as this and ask one to calculate the surface area of the rectangle. But then someone says that to calculate the surface area of the rectangle, you have to multiply the two dimensions. But what about that person who doesn't know that formula? So comes the next level of simplification. Calculate the area of the rectangle, multiplying the length by the width. Then someone says that, well, this cannot be cast in a multiple choice framework. So choose the correct surface area of the rectangle in consistent units. So you are given 3 or 4 answers and you have to select it. So up to this extent, what I would imagine was the evolution from the descriptive era to multiple choice era. But then came the simplification era. So the simplification era is multiple choice, but obvious indicators of eliminating the wrong answer. People always need to stretch or blow up things a little bit to convey the inner message. So choose the correct surface area of the rectangle. So I've given some A, B as two absurd choices which would never be correct, and therefore C is obviously the correct. Now the present evaluation has become more advanced than this, that A and B, instead of that much obvious, could be a bit of non-intuitive, so that someone who doesn't know it correctly will fall in trap and possibly make some mistake. So the objective of this type of education, when stretched to engineering as well, is to eliminate some people out of a competition rather than developing certain skills that they should acquire for their future. And simplification has gone to a certain extent, and I would extrapolate that to make everyone happy. The last question is a great question. Color the rectangle with the color of your choice. So it might appear to be oversimplified, but I think we should start from here. That color the rectangle with a color of choice, your choice, might appear to be something which is, it's no more a question. It is like a kindergarten class exercise of a child. But if you see that child with the imagination of a very young mind, had that child been equipped with some knowledge which potentially he or she would acquire in the future, I think that combination is something that cannot be trivially told as an unintended skill. Now, before I enter into the main points of what I'm going to talk about, I would confess that over my years of experience as a teacher in engineering, I have learned certain lessons, and these lessons are not static lessons. Those lessons are dynamic and they change. But I thought that these are certain things that I wanted to put that in the evolving era of this education, be it engineering or non-engineering. I do not want to make a big distinction between engineering and non-engineering education in the backdrop of the modern interdisciplinary era. In IIT Kharagpur, we are having a framework where we would be having medical education also. And we have currently some education which is at the interface of medicine and technology. We have different educational programs which are at the interface of engineering and basic sciences, humanities, etc. So overall, this applies to all. I think the first one is what we as teachers forget: respect what the students expect and need. Over the years, I have seen people developing curriculum and curriculum development and revision has now become a routine practice, mostly to show that the curriculum is being changed. And therefore, in many cases, what we see that it is a ritual where old wine is put in a new bottle. And it is likely to be so because seldom we see that these things are done with not much respect to what the students expect and need. On the contrary, we all tend to say, oh, modern day students are not at all sensitive to the engineering or higher studies in that way. They are more interested in certain kinds of jobs and career building, and therefore we develop our own towers, and it seems that there is no consumer of the buildings located or the apartments located in the same tower. So we should be responsive to the evolving challenges, resist the temptation of establishing superiority, teach and preach. So it is like what I would say, teach and don't preach. That is the motto that we should take forward. Emphasize on fundamentals and interpretation between lines, and highlight on possible wrong concepts on critical topics. It is very, very important because the lines are already available from books and from books to ChatGPT. So in the era when you have the generative AI reproducing the items of the book actually in a more organized fashion, in a bulleted manner as compared to what is there in the books. So the emphasis on these fundamentals and interpretation between lines is going to be more and more important, because we cannot ignore the classical contents of any education and just focus on what is the modern trend. Refrain from overuse and abuse of technology is very, very important, because with years of my own experience as a student and as a teacher, I realized that for certain topics, to make the students understand and apply that even to the evolving world, the chalk and talk appears to be the most useful method. It may not be the most attractive. If someone asks you a question that what innovation you have made in your teaching, maybe in some interviews nowadays, this is asked for teachers for their promotions and other things. And I find that people telling all sorts of things. And I'm still looking for that teacher who takes the courage and says that my only innovation is to see that how sincerely and effectively I can communicate the knowledge that I have for the improvement of the conceptual learning of the students by using the chalk and talk as the primary method, and still distanced from several of the open resources that are available in the internet on the same topic. And teach by examples, distractors or humor is a very, very important point. And I think that in the evolving era that I have learned that traditionally we have been having classes which are long. But now in the era when everyone is having an attention disorder, primarily because of the rapidly changing contents of the smartphone that we are continuously browsing. So when the attention gets diverted, we perhaps need lots of examples, distractors and humors to bring the attention back to the main topic. And I'm afraid that these are the steps that are very important, but currently no AI based content exists which will take this role and rule out a human teacher. Because many times we talk about the importance of AI in the teaching framework, and in engineering that is more relevant because there are lots of technology centric topics which AI driven methods could be very, very attractive. But I'm afraid that there are certain aspects that a teacher would always have, and AI is still far from that. So while we continue to make use of AI, we should keep these aspects of golden learning from our own experience. So to summarize the points covered so far, the changing context from industrial age to the intelligent age, or the intelligence age rather, every age is intelligent. So industrial age started with the industrial revolution, and most of the engineering contents in the classical sense have been developed centered around that revolution and the prior learnings which came before that revolution, but they can be connected to the outcome of the revolution. So from that age, we have come to the age of intelligence, and it has AI, automation, and open web revolution. With this, the old style of teaching learning is going to be completely ineffective. I can remember that when I was a student in school, who was going to be considered a very good history teacher, a teacher who would be memorizing the important events that occurred in the past history with their dates, names of the characters, and the description of the events. But then, in the modern era, when someone is interested to learn about those events, you can give a simple keyword-based search in anything, starting from a generative AI framework to even the standard search engines, which have partly AI augmentation nowadays. You will realize that you will get much more detailed answer as compared to what the best of the human teacher could keep in his or her own memory. So what are we now expecting from a new generation history teacher? But so history is symbolic here. I would mean a teacher who is describing or who is teaching a descriptive subject, a narrative subject. So what we now would perhaps require is a teacher who, given the information that these things have already happened in history, would be in a position to give a perspective to that, the learnings from those, and perhaps how those learnings can help to build up the things in the future. With the open web revolution, on every topic, you will get excellent open web materials, starting from static materials to YouTube videos. And therefore, we have to see that an education system should be well positioned to make use of these rather than being ignorant of that and developing our method of teaching learning in the way in which we have traditionally been habituated and we feel that they are important. Now, as we are advancing in technology with AI, automation, etc., human-centric challenges crop up. So now with image processing and video morphing, it is possible for anyone to reproduce fake videos, or rather to produce fake videos, fake images, and so many other things which are unethical. When we were in school, we were asked to write an essay, science, a blessing or a curse. I think that with the modern day AI, automation, and open web tools, The same question we are asking as educators, that are these blessings or curses? Answer is neither blessing nor curse. It depends on how it is used. And to use it, as I told in my convocation address at IIT Kharagpur, that as humans we develop algorithms, but algorithms should not dictate us that what we would do. Rather, we should solve human problems by making use of those algorithms, methods, or learnings of engineering, which need not just engineering skill, but empathy and ethics embedded into that. That brings us to the gap in traditional education. And if we talk about the traditional education, there are so many aspects of traditional education which we can say that are relevant in the higher education or engineering education, but some of those are more relevant in higher education or engineering education as compared to the rest. So we will come to that. If we come to traditional education, the rote learning dominates. If some of you are not familiar with the terminology of rote learning means memorization technique based on repetition, where information is churned by practicing until it's stored in memory. And this is based on our traditional exam system, which we say in loose sense, commit to memory and vomit on the paper. Still that dominates. And many other offshoots of what we are seeing in these days as challenges in managing engineering. Today, just before this talk, we were having a meeting with some of our very senior officials, and I realized that exam malpractice is one of the very great challenges because of the different tools that those unethical students would use. But then, if we do not have this commit to memory and vomit on the paper type of exam, I think that to a large extent we can minimize the malpractice that we have in different forms of traditional exams. These types of learnings are also largely disconnected from industry and society, which are rapidly changing. And these kinds of learnings are usually without purpose or confidence. All what it means is that I should not say without purpose. The purpose is to pass exams and do well in exams. But that cannot be defined as a purpose. And it doesn't set up a confidence in someone to address the challenges of the working world in the rest of the life after one graduates. So it is very important to get into what we call as feel, think and build philosophy, which is the central theme of today's discussion. Feel, it symbolizes empathy and awareness of the context. So as a teacher, when I go to class and teach a subject or teach a topic on a subject of a subject or a chapter to be specific. Now sometimes even the best teacher will come and start teaching the subject without creating any context of why it is important in what the student will miss if the student never learns that subject. And if it is learned, then how can it be used for certain purposes? Then think, critical and interdisciplinary reasoning. As I was giving the example of history, that not just narration of events, but critical analysis of the events. And these may be easily introduced by, for example, introducing some impromptu debate events as a part of history evaluation. Build. This is important in engineering. Hands-on, impactful, real-world engineering. Build something. What is that build? It may not be a physical item. It could be a software, it could be a code, or it could be anything. So once you build something, so here build is symbolic. Build doesn't mean that it is a physical building that is being built. It is the building of an entity, whatever may be the entity. Through that building exercise, the student is exposed to hands-on, impactful, real-world engineering, which anyway requires synthesizing the foundation engineering knowledge and the modern skills. The National Education Policy 2020 offers a unique opportunity of transforming some of these aspects into practice. There are several pointers, and I would like to highlight 3 important points which are strongly relevant to engineering education. I have myself participated in several workshops on NEP 2020, some as an audience and some as a speaker or panelist. And what I recognized is that in many of these workshops, people would tend to read out the contents of that NEP Foundation book. And in fact, that becomes like what you call as ironically rote learning of NEP. That means information on NEP is learned by churning certain keywords, but it is not giving us the in between lines what we can do. As practicing educational leaders by leading certain institutes, we all recognize that multiple entry exit is a very important concept. But how can we give that flexibility with certain constraints which are existing? Multiple exit has not much problem, and the philosophy of multiple entry exit is that on a given topic, let me give example as AI, because that is a topic of everybody's interest today. Someone may be interested on AI, on the foundations of AI, and then maybe a 6-month or 1-year course with certain hands-on is good enough. Someone says that no, I want some additional foundation skills, and then maybe 1 more year. So in that way, people who did not have a reasonable prior background on AI can enter and exit at different levels and accordingly get certificates, diploma, and maybe after 4 years a degree. And it is quite clear that what you achieve out of each of these individual exit milestones. But what about multiple entry? In our system, like I represent the IIT system, the entry of the IIT system in the undergraduate level is so stringent that multiple channels of entry or multiple levels of entry, for example, someone studying BTech in IIT in certain course coming through JEE Mains and JEE Advanced, and then suddenly in second year we admit someone whom technically we feel that that person is capable to enter the second year, because there would be some assessment which reflects that the person has adequate knowledge with high level of proficiency in the first year content. But will our present system allow that person to enter? So there are many such open-ended questions. We want interdisciplinary courses, but if everyone is having the flexibility of attending every course in the institute, we may have a timetable chaos. So I have a possible solution that the academic units or departments introduce their own interdisciplinary courses by taking help of other units and their teachers. And the teachers of other units participate in that. I come from a good old engineering education system which had a practice like different styles of teaching so-called departmental and non-departmental courses. So being a mechanical engineering student, I learned electrical engineering from some of the best professors, but customized for mechanical engineering students, or rather customized for the students who are not from the core electrical engineering. So in that way, interdisciplinary courses can be prepared in the modern era with a lot of focus on skill and project and activity based learning. And to the large extent possible, if the skill based, project based and activity based learning can bring in extra credits to the student, the theoretical dictum of learning will, what I would say, slowly give way to a mixed mode where there will be tradition, but tradition will be concept based rather than memory based. And the modern is more application oriented perspective of how we can apply that tradition in a problem solving mode or in a project execution mode. So the entire aspect of this activity based learning should bring in credit points where there would be no more lot of emphasis on traditional exams, and many of the limitations of the traditional exams will in the process go. So when we have these open source items, and as I mentioned in the ChatGPT era, I asked some of our colleagues that if the 4-year BTech program, if in the 4-year BTech program we have so many exams, and if we put the questions of those exams to a generative AI framework, say ChatGPT, now how will ChatGPT perform? And to a large extent, the kinds of straight-jacketed questions which are put forward, even if they are tweaked significantly, those tweaked versions of the questions are also known to a large extent, and a generative AI can grab that from an open web source. So ChatGPT could perhaps get excellent grades in most of these exams. So if that is possible, then what is the role of a student? We sometimes prohibit the student from using AI. It is actually out of our own fear of losing our identity and importance. And in most of the cases, it happens to be like that. We feel a bit insecure that in the era of AI, our identity as a teacher, that definition is under question. But all what we have to remember, that teachers in the modern engineering education would have a different role, and I would come to that. But in that role, we should have strong emphasis on AI-driven personalized learning, which the students at their own comfort of their home or hostel can learn from openly available resources, simulators, and in that way, using all these toolboxes or tools which are available, we can make them more context aware people having modular education, where every module of education has a purpose and it grades up from the foundation to the applications using the interdisciplinary framework. Now, over my entire journey as a teacher, I have always tried to experiment with certain things. Instead of giving concepts which are over theoretical, I always tried to give examples. And I learned the need of these examples from my own experience. When my son was about, say, 3 years old or so, like all the parents, we were confused that, whether he will be interested in music or maybe sports or, many other things. So we organized a music teacher, and the music teacher came to our home, and he started with some theoretical aspects of Sargam, and that was it. I think with that deadly impact of theoretical knowledge dissemination, we all found that enough is enough. Possibly, he is not going to enjoy that anymore. Now I realize that had I been a teacher like him, what should have I done? My simple answer would be that instead of getting into all those, I would sing a small catchy song befitting to that age and tell that you try to mimic me, with an intention that he can reproduce that in the annual day event of the school or any other function. Now that would drag the person or drive the person into the field, and then with time you can infuse more and more additional or advanced learnings. In the fluid mechanics, which I have been teaching as a subject over the years, we talk about conservation of mass, conservation of momentum, energy, and so on. And I have kept on telling that those are important, but in the life we all feel that money is very important. So I have started, for quite some years back, started giving examples of the bank balance, of money balance, whatever you say, is, as a rule, the practical way of understanding conservation. As era evolved, different situations came up. So in the COVID era, we faced the challenge that we all face now. A glimpse of that challenge was faced at that point of time, because all exams and evaluations were online, and it is impossible to keep a vigilance of what is going on during the online exam for so many people. I mean, if you are having a controlled exam on a few sets of students, it's okay, but when imagine IIT Kharagpur has 16,000 plus students. So what I did is, in one of those subjects, where the we were talking about fluid mechanics. So this is something which it is an experience in my own washroom. So one day when I was there in the washroom, I found that certain things occurred. It's a bit of a challenge, where the nozzle in the head of this spray nozzle, it got dismantled, and when the water was coming out of this, I found that it was this entire system was dancing like a dancing snake. So I just took a video of this and asked them to explain the observed thing with some physics and some mathematical principles. So try to innovate things to an extent that in the last semester, and you can see the question paper in it was in February 2025. I gave a style of question where I reproduced certain items with, I gave questions and ChatGPT gave the answer, and I gave them the answer which is given by ChatGPT, and allowed them to sit in the internet to get into more inputs if they want, except for having access to a chat tool. And then they were asked to answer certain questions based on the ChatGPT answer, and possibly figure out what was missing. So in that way, as we are progressing, the futuristic engineering education has to adapt what we say as a DNA of learning, where we have the Western approach of external and Eastern approach of internal. So fusion of Western and Eastern philosophies to inspire leadership development, and it is portrayed by Dr. Partho Ghosh in our Partho Ghosh Academy of Leadership, where we are trying to pose engineering education as a means of inculcating leadership in the young minds. So beyond engineering, the education that we are looking for, it should have morality and purpose, ethics, responsibility and inclusion, balance of East with values and West of innovation, and education for humanity and not just for utility. So in this evolving era, we should have institutions as innovation ecosystems, studios having co-creation with industry and society. Faculty like us should be defined not as instructors. We may have instructors who are different from faculty, but faculty as mentors and students as builders of solutions. So the scientist's mind, entrepreneur's drive and humanist soul. If you say, what is the vision of a future engineer? I am not an artist, so I cannot paint it in the way in which I would have liked. But a future engineer should have the mind of a scientist, the drive of an entrepreneur, and the soul of a humanist. And they should design machines and a better world all together, and not just machines. We all talk about education, and education is something which is for students. And when students are there are so many aspects of well-being of students which do not come into the purview of what is our straight-jacketed teaching learning exercise. And this gives rise to many challenges, including mental health problems and so on. And of late, we have tried to connect with students with different wellness initiatives, total 360-degree initiative with modern science and technology, scalable and AI integrated system with Indian value system and human touch, all combined together by a single platform called as Setu, which is a bridge which connects between darkness and light, and ignorance and knowledge, and hopelessness and hope. So mind, body and soul, which are the different elements of a student's growing up, we believe that it's a holistic approach that needs to be impregnated with not just education, be it foundational, be application oriented, that should be supplemented with the life skills for individual growth, like personality, cognitive skills, coping skills, interpersonal and communicational skills, and so many other aspects which in a loose sense we call as soft skills. And this era is an era of both EQ and IQ, emotional quotient and intelligence quotient. So in this era of survival, or I would not just say survival, but also to advance as a leader, one should have engineering education, having each of these life skills learned in certain ways, could be through workshops, through short courses, and through certain toolkits. So the bottom line is feel the world, think deeply, and build responsibly. In the era of AI, the most human engineers will lead and enable the students to build themselves and not their CV. So in a way, we should have certain key takeaways for every stakeholder. For policymakers, implement flexible NEP-aligned frameworks and incentivize innovation, incentivize participation, incentivize the engagement with community, society, and developmental work, and keep that as a credit point in the curriculum. For educators, redesign curriculum for empathy, adaptability, and project-based learning. For students, cultivate purpose, curiosity, and real-world problem solving. And for industry leaders, partner in skilling, mentoring, and innovation ecosystems. This is all what I wanted to present as a structured framework